Good afternoon, everybody. We have a special guest today from South Carolina, but he's from Morocco. Dr. Houssain Kettani. He received his bachelor's degree in electrical engineering from Eastern Mediterranean University in Cyprus, and master and doctoral degrees in both engineering, electrical engineering from the University of Wisconsin, Madison. Maybe you can tell us, Wisconsin is in the state, is it?
Correct, yes.
Yeah, okay.
Near Michigan.
Okay. So Dr. Kettani has over 20 years of academic experience. He served as a faculty member at different universities in the United States, South Alabama, University Polytechnic, Fort High State University, Florida Polytechnic University, where I think he lived, Dakota State.
Professor Ahmed, we cannot hear you.
It's frozen.
Yes. He will be back. I think maybe the net, maybe. He's not there. He's back. You are muted, Professor Ahmed.
I had some problem here in Germany, I guess. So anyway, I want to thank Dr. Yes?
We miss your introduction to Professor.
The whole staff, or only part of them?
No, till you reach, I think, Los Alamos.
Yes, it's fine. Yes. So I want just to thank him very much. He's always with us, even on social media. I guess he follow us. I think he's a lover. He loves very much Morocco. I know this, and Muslim world. I think he wrote a book on statistic of scientists, I guess. Is it? Can you correct me?
It's demographic statistics since the time of the Prophet until 2100, until the end of the century.
I think you should show
like,
us. You should
two
maybe.
books in,
Okay.
Yeah.
You should maybe show us your books at the end of the talk.
Please send us the reference. Yeah.
Or the reference, because a lot of people from our world, they have to know this. So,
Okay.
so he
I
cared
can give a
about.
presentation later about that.
Oh, sure.
That could be nice also. Yeah.
So he is very much concerned about the Arab world, the Muslim world. I know this because I follow him also on social media. That's why social media is sometimes very interesting. There is pro and con on social media. So I want to thank him very much for coming here to give us his something from his expertise, and he will talk about in Arabic we call التقدم في الحاسوب عالية الأداء, so the advanced computing, and I want to give him the floor now to continue his talk, and I hope we will have a very nice discussion. And sorry for this interruption. It's the Wi-Fi in my home, which today doesn't work very good, I guess. So the floor is yours, Dr. Kettani.
Thank you so much, and it's really refreshing to hear these terms in Arabic. I think one of the contributions of the virtual learning university is how to normalize such discussions in Arabic and these terms that we get so much training, like words like cybersecurity, high performance computing, and other terms that if you want to give similar talk in Arabic, it becomes like it's very hard because those terms are not something you hear much, or even you know how to translate them in the right way.
That's true, yeah.
So so is my presentation on, or do I need to share it again?
You have to share the guest.
Okay. So
It's fine.
it's fine. Okay. Let me now try to see. Okay, well, thank you very much, Dr. Nawi, for such great introduction. Thank you for the VLU for the invitation and this wonderful and extraordinary effort that brings researchers from all over the world. And one good thing that came out of this pandemic is that we got kind of a good training and in using remote conferences and remote meetings, and that's and VLU is a good a good example of making this this a possibility, where people from different continents agree on specific times, sometimes early morning somewhere and late at night somewhere else, and so it's very much exciting to meet researchers from all over the world, and including researchers from Morocco and the Moroccan diaspora. So this is a very hot topic that I'm talking about, HPC for short, or high performance computing. And an introductory course in algorithms in computer science, the first thing that students see is this equation. It looks very simple, and it's simple indeed. It relates time with a count, with a number of basic operation in an algorithm, where basic operation is something that takes time to execute in an algorithm, say number of multiplications, for example. And so times number of multiplications times how much each multiplication takes to execute. And when you multiply a number with time, you get a time unit, which is an estimate of the running time of an algorithm. So it's straightforward, but in algorithm, we only discuss the count of the basic operation, and then the class, big O, of something. Is it linear? Is it logarithmic? Is it exponential? Is it factorial? And what does this equation do is that it makes the discussion and analysis of algorithms independent on technology. So I can study an algorithm and compare a newly proposed algorithm with an algorithm that was proposed 100 years ago, before there were any computers, because it's not fair to compare two algorithms on different machines, on an old machine and on a newer machine. So that's why in analysis of algorithm, the discussion is usually about the count and not the time, because you get that, because this is affected by the current technology and as we progress with the speed of computing. So typically, so we go from good to worst. Like this is logarithmic. The class of algorithm makes it good. Linear is good. N log n still good. Quadratic, n cubed, these are called polynomial, and still they are not horrible, but they're not as good as linear and logarithmic. And here you get to a horrible algorithms where it's exponential and factorial. An example of that in algorithms is knapsack problem, is exponential, and traveling salesman problem. These are brute force algorithms proposed for these are in that category. And I'm going to discuss what does that mean. So for example, for only 10 elements, input size, say if you are talking about knapsack 10 elements with weight and value individually, or traveling salesman, if you have only 10 cities, then this becomes 1 million. And then if you have 100, then you can see this is out of control, especially this one. And then if you have 1,000, It's like even computer cannot handle just calculating this with almost 3,000 zeros next to it. So, so in parallel computing, also referred to as divide and conquer, you have a problem with input size n, and then you divide it into sub-problems. You send each smaller problem to a processor, you get the solution, and you gather all these solutions, and then you get the original solution. For example, if I'm adding 1,000,000 numbers, I can send 1,000 numbers to 1,000 processors. So I get the sum here, I get the sum here, and then I gather these 1,000 sums, and I get this sum. So these little problems are being solved in parallel, and that's why we call it parallel computing. And that usually saves us time if this function is small. So that's the basis for supercomputer. Now, the picture that you see here is the proposed fastest supercomputer, the first exascale supercomputer in the world. It's being now assembled. It's already ready. It's being assembled at Oak Ridge National Lab, and it's going to take a few months for it to run and do the test to certify. It's expected to be 1.5 exascale, the speed of it, but it's not going to make it to the top 500 until tests come. So the list of top 500 is going to come in November next month. So I don't expect it to be on the list then, but hopefully it's going to be in June. So it looks nice from the front. From the back, this is how it looks like when you go to the room. And I worked at Oak Ridge National Lab for several summers. From the back, you see all these processors, and these are like what's called blades. So it's like if you think a stack of 30 computers on the top of each other. So it's pretty noisy. They have fans. The room must be cold and temperature controlled. It's raised. The floor is raised because you have chilled water going down to cool the room. A lot of things are controlled in the room, but it's pretty noisy and it's expensive to run these things. So fastest we say is Frontier at Oak Ridge National Lab, performs 1.5 exaflop per second. Exaflop means quintillion or 10 to 18 calculation per second. So in comparison, in 1985, we hit the gigaflop ceiling. The fastest computer in the world was in gigaflop. So now my smartphone is faster than the fastest supercomputer in the world in the 80s. And imagine that. So that, like for Frontier, it occupies 2 floors. Each floor is 1 acre. So 2 acres of equipment. And now I can have that in my pocket and do it for other things, not just nothing scientific, games and other things, and Facebook and other things. In 1997, we hit the teraflop ceiling. Petaflop was hit in 2008. And then we expect to hit the exaflop ceiling in a few months or next year. And so going with that, if we do linear extrapolation, there is zetaflop at 10 to 21, maybe by the mid-30s, and utaflop or 10 to 24 by end of 2040s. And what is after the utaflop? 10 to 27, there is no name for it. So we are going, so the English language is trying to do a catch up with the speed of computers. This exaflop computer Frontier consumes 40 megawatt of power. So it's more power that is consumed than a university campus, for example. So this is not something that some universities have supercomputers, but they are not at this scale because it's very expensive to maintain. You are talking about not only equipment, you are talking about power, you are talking about personnel that handle it, you are talking about things that go wrong at this very high, large speed. So what are the implications? Exascale computer has processing power on the order of processing power of the human brain at the neural level. So you can simulate to some degree a human brain. This is excellent resource for machine learning, data analytics, artificial intelligence, cybersecurity, as I'm going to discuss few of these things as we move on in this presentation. And I just mentioned these because these are areas that I worked on and published papers on. But this speed of computing is extremely useful for anything you can think of. Like I've seen a lot of presentations at VLU. Probably now we had like between 20 and 30 presentations so far, and on each topic you can think an application of a super computer that can make things better. So you can have input to the training machine that makes it that makes the design smoother, that makes the analysis more accurate, that makes the forecast better. If you're talking about weather, forecasting storms, forecasting hurricanes, for machine learning, also like understanding human behavior, mapping faces to real people and identity. So when we think of artificial intelligence, many times we think of robots, but artificial intelligence, it's like algorithms that can analyze things and bring solutions, which with the training, with the amount of data that they are trained with, and with the speed, how quickly they can make the decision. So now they can make it like online or in real time because these speeds are going higher and higher. And then with cybersecurity, it means you can crack codes much faster, and you can do other things that that threatens the cybersecurity. Something that you hear a lot about is quantum computing, and it was shown for a specific problem that it's a trillion times faster than the fastest computer. So we're talking about 10 to 30 calculations per second. So there is so if we want to say like exascale, there's no word for that. There's researchers did not agree on a term for that because of the imagination. And so so Google's Sycamore quantum processor was an example that showed that solved the problem that it would take the fastest supercomputer 10,000 years to solve. And there is a saying in the United States that the country that outcompetes. So there is competition between top countries to have the fastest computing resources, because that's very useful for research and also for national security. So here is a top historical graph from top 500 that started, the listing started in early 90s. So when we were at the gigaflop range. So the blue one is number 500, and the orange one is the fastest at that time. And each triangle here, or each dot, is 6 months. So you can see when you do linear extrapolation, you can find a very good estimate when we're going to hit the exaflop computing. And this is using the classical approach to the classical binary approach to computing, not the quantum one, not the qubit, where one bit can be at the same time 0 or 1. So therefore you can use it to store more data, and therefore you can use it to solve more problems in a much faster time. So so when we talked about frontier, so you can see for this, like 3 years, the fastest supercomputers remained there around 2015. And then you can see the fights between countries, typically United States and China, and from time to time Japan. And so there's a competition here until one wins. So there is sometimes it comes periods where it becomes flat. So the technology takes a lot of resources to just break through, and sometimes there is a fight where each 6 months the list comes out, like in June in the supercomputing conference in Germany, and in November in the supercomputing conference version in the United States. And so you can see sometimes there is a fierce competition. Now there is a fierce competition who's gonna get to exascale first, and it looks so far that it's gonna be Oak Ridge National Lab in Tennessee, United States. So when Oak Ridge made the announcement that we're gonna have Frontier, many people said, well, we are like the direction is not this binary thing, is not investing in this kind of classical approach to supercomputing, but the direction should be quantum computing, because you can see that it's orders of magnitude. So it's like trillion times faster. But that's still work in progress. There is physics, there's the theory, there is a lot of things that need to be worked out to have a functioning quantum computer, and at that level, eventually, maybe in 10 years or something, maybe end of next decade or something like that, we're going to have laptops that are quantum computers. And imagine what you can do with that, like a laptop that is trillion times faster than your current laptop. So here's a top list for here's a top list as of June. So it's going to be updated next month. So in a few days or so at the supercomputing conference. So now the fastest supercomputer is Fugaku in Japan, and it consumes 30 megawatt. And so Frontier going to consume even 10 more megawatts there. So you can think of it this and this. Summit is currently what is at Oak Ridge National Lab and being disassembled because its space is being occupied by Frontier, the supercomputer that we just talked about. So you can see here 1, 2, 3, 4. These are the top 10. So 6 of them, 1, 2, 3, 4, 5. 5 of them, half of the top 10 is the United States. We have Germany here, and it's number 8. And you have China occupying 2 of them. This used to be the fastest supercomputer in the world for many years. So that's the list. Well, the fastest supercomputer in Africa just made it. Actually, Africa just made it to the list top 500 in 2019, and thanks to Topkal supercomputer at Mohammed VI Polytechnic University in Ben Guerir in Morocco, just north of Marrakesh. And it's the most powerful. It's ranked 130 on the top 50, top 500 list, and it performs 3 petaflop. So it's great. And of course, for those who are not familiar with Morocco, Topkal is just it's the highest summit in North Africa. And I think it's the second highest summit in Africa, and it's just outside the city of Marrakech. So it's very, very close to where the supercomputer is. So let's compare a supercomputer to a PC. A PC achieves, say, a good PC achieves 1 teraflop. If you want to check what is the speed of your laptop or computer in terms of flops, you can check this website at Intel, and so about 1 teraflop, a good computer, that's the speed of a good computer. So so a supercomputer is about 1 million times faster than a PC or a laptop, and so 1 second in a supercomputer is more than 12 days in a PC. 1 hour in a supercomputer is more than a century in a PC. So what does that say? Problems that were unsolvable before, now they are solvable, because you cannot wait for a century to solve a problem, but 1 hour you can that's doable. And in fact, with quantum computing, 1 second in a quantum computer is more than 30,000 years in a supercomputer. So we are going fast and real fast. And with that, problems that were not solvable in the past, now they are solvable. And even no longer with these fast computers, the unsolvability of a problem numerically, maybe theoretically it's hard, but numerically becomes not an issue in science and technology. So how slow is is a slow algorithm. So for example, we have a knapsack problem. We said it's exponential. So if it has 100 elements, then it's 10 to 30. So suppose we use one exaflop, say we use to solve this problem, a knapsack problem with 100 elements. So that means that the basic operation the speed of the basic operation is inverse of this, which is 10 to minus 18. So if I do the math to calculate the running time, I multiply this 10 to 30 with this 10. So I get 10 to 12 or a trillion seconds. So a trillion seconds is about 32,000 years. So if I use the fastest supercomputer currently available to solve this problem, I need to wait 32,000 years. But if I use a PC, it's gonna take this much. So it's probably more than the age of the universe. But with a quantum computer, the same problem can be solved in 1 second with a quantum computer. So okay, so here is a knapsack problem. It's a constrained discrete optimization problem. So given n elements, weight, and each one has a weight, each one has a value, and you have the constraint is the capacity of the knapsack is big W. You want to find the most valuable subset of the items that fit into a knapsack. So it's like something like a thief trying to gather valuable things but cannot fit big things that are heavy in their knapsack. So a brute force or exhaustive search algorithm is exponential, the one that we've seen earlier. If I apply dynamic programming, the problem is solved in linear. So the ingenuity of human brain, it's still important in solving algorithms. So while the speed, while the technology may make us lazy and make us dependent on technology, theoretical analysis of algorithms and developing smart ways to solve problems is very important, because here you moved from exponential to linear. We do not have that luxury for traveling salesman problem, for example, which is even worse. It's factorial, but still, maybe there is a researcher out there, a young researcher, a student out there that can come up with a solution to the traveling salesman problem that reduce it from factorial to something much better. And you couple that with the speed of the technology, then the problem becomes much easier to solve. So advanced encryption standard with 128 with a key of 128-bit. Let's see that. How can we crack it? So with an exaflop supercomputer, it's going to perform 10 to 18 if we assume that each number of flops required for each combination is 1,000. So we do the math, etc. It's going to take 10 quadrillion years with the exaflop supercomputer to crack this code with this kind of encryption. Even with the quantum computer currently, if we have a functioning quantum computer, it may take 10,000 years. So it is still secure. So is it gonna really take 10,000 years? Is it really gonna take this much? So is it really secure? Well, of course, there are other shortcuts. You invest billions of dollars to secure a system, but then you get a whistleblower like Snowden, for example, or Assange or Chelsea Manning that just spills the secrets. So there are shortcuts to break cybersecurity, but we are just talking about the theoretical and the strength of cryptography. So we saw from the previous graph, from the top 500, that to go from this to this, it takes around 12 years. And so accordingly, a performance at the zeta scale, this and the Utah scale, is projected to be achieved by mid-30s and late 40s. So by then, still, it's going to take 10 to 10 years to crack AES. So with that speed, maybe by the 2090s, it's going to take a few days to crack this advanced encryption standard. But this is excluding the possibility of quantum computing, which could be a trillion times faster. So if we have a functioning supercomputer and it's improved, maybe by the end of next decade, we can crack this. And this is basically this is certified to encrypt data at the top secret level. So in the 90s, we were like processors with the speed started heating up. So when it heats up, material melts, and so then the processor. And so so it was so a physical problem that engineers found a solution for it to. So instead of putting one processor, I put two processors, and then they were the words duo means two processors, or quad means four processors. And so you were thinking, well, okay, so if the speed is 1 gigahertz, then if I have four, then I'm gonna have the speed of 4 gigahertz. But then engineers passed the problem to software engineers because, well, if the algorithm I'm using is a serial algorithm, then the maximum speed I can use is only the maximum speed of one processor. So it became a software engineer problem, how to use different processors simultaneously. And so software engineers worked on parallelizing software, operating system, how to use multiprocessors to make these things. And that was possible. So that's something that was happening in early 2000 and early 2010s. And so we were able to have software and operating systems that can work on multiprocessors. And now even your smartphone is multiprocessor. The question is it every problem that can be solved in serial can be solved in parallel? So a building, can I start a building from the middle and build it? No, I have to build it from the bottom. The closest I can get to building in parallel is to build each floor separately and then assemble them like a puzzle, like a Lego. The same thing about the bridge. I cannot start in the middle. I have to start somewhere close to the earth and then keep moving. Maybe start from both sides, or maybe build it in modules and then assemble the modules. So that's the closest I can get to parallel processing. One example that is given in the literature that is not solvable, and of course researchers don't like to say the word unsolvable unless it's proven that it's unsolvable, is pregnancy. Can you give 9 ladies 1 month each and then get a baby? That's scientists are not there yet, but that's currently is an impossibility. So that's an example of a serial problem that you have to wait for the development of the fetus, that you cannot do it in parallel. Other examples I worked on, so you have number representation. So this is like, say, from decimal to binary, but it works on any numbering system. And this is radix point, this is a fraction, this is integer. And so the way how we teach it in schools is to, if I want to convert this to from here to decimal, I sum these things and then I get the decimal part. But if I want to go from decimal to binary or to base B, what I do for the integer part, I do repeated divisions. For the fraction part, I do repeated multiplications. So here's a numerical example. If I want to convert 41 to binary, I keep dividing it by 2, and then I record the remainder. And then this becomes, because I divided the most, it becomes the most significant digit. So this comes here, and this 0 comes here. So 41 in decimal is this in binary. So I cannot, so to get to this number, I had to keep dividing. I had to get all these bits before I get this. So before I get this binary value, I had to get this. So this is working in serial. Similar thing to get to the fractional part, I keep multiplying it and record the integer part, and then this becomes the most significant digit. So this becomes like this, and this is in binary. But here is a base conversion theorem that I proved and I published before. So it says, if you have this kind of representation, if you ask me, then I just need I can find each digit independently than others using this formula. So I just need the position of the digit, I just need the decimal value, and then I need the base. So the base, if we are talking binary, it's number 2. If we are talking other base, then it just, you plug it in here. So only 3 variables, and I plug it in here, and then I get each one of these independently than others. And this is that kind of independence. If one is independent, then a bunch are independent. So what does that mean? It means I can get a bunch of them to each processor and do the algorithm there, and then gather all the information just in juxtaposition of these numbers, and then I get these things. So this is a proof of concept of a problem that is known to be serial number, a serial problem that we moved it from that with theoretical analysis. We found an algorithm that we can solve in parallel. We can solve this problem in parallel, that historically known to be a serial problem. And that ends my presentation. Here's a cartoon for you to laugh at. And I open the floor for questions. Q&A.
Prof. Ahmed, your mic is closed.
Thank you very much, Dr. Houssain Kettani. Before we start questions and answer, I would like to give a small brief in Arabic. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. أشكر الدكتور حسين الكتاني أستاذ من جامعة كارولاينا الجنوبية بالولايات المتحدة. تحدث عن التقدم في الحاسوبة عالية الأداء. قبله في اليوم الأول في الافتتاحية أتيحت لنا الفرصة لسماع البروفيسور قيس صابر من جامعة بيردو في إنديانا، الذي تحدث عن الكوانتم كومبيوتينج على الحاسوبة الكمومية إذا صح التعبير. ونريد من هذه الزيارات من السيد قيس والآن من السيد دكتور حسين الكتاني وهو مشكور، نريد من الطلاب وزوار جامعاتنا والمجتمع أن ينموا ويستفيدوا من تقدم تكنولوجيا الحاسوب أحدث ما توصل التكنولوجيا، ودكتور حسين تحدث عن كل هذا. أبحاثان مثلا تحديد توليد مواد تكنولوجية المستقبل، فهم أنماط الأمراض وأسبابها مثل كوفيد 19. كل هذه القضايا تتطلب معالجة كمية هائلة من البيانات الضخمة، وهذا يتطلب قدرات الكمبيوتر العالية الأداء توفرها أجهزة الكمبيوتر العملاقة التي تحدث عنها، وأيضا تصميم الخوارزمات. لا بد أن نتحدث أكثر وأكثر. دعونا نضع على هذا النحو. يمكن أن تكون أجهزة الكمبيوتر العملاقة أكثر قوة معالجة بمليون مرة من أسرع الكمبيوتر المحمول، وأظن هذا ما قاله دكتور حسين، وصححوني إذا كان المليون غير صحيح. وقال
مليون تريليون
تريليون. إذن قال أيضا 12 يوم يساوي ثانية واحدة بالنسبة إذا قارنا المعالجة بين الكمبيوتر المحمول والسوبر كمبيوتر. هل هذا صحيح؟
نعم.
تتفوق أجهزة الكمبيوتر الكمومية التي تحدث أيضا عنها بشكل كبير على أجهزة الكمبيوتر العملاقة عندما يتعلق الأمر بكفاءة الطاقة، وأظن أن هذا أيضا مهم جدا. أعجبتني جملة عندما قرأتها في السمري في الملخص الذي رسله لنا الدكتور الكتاني، هذه في نهاية ملخصه: للمؤتمر الذي قدمه أقتبس: نحتاج إلى أن نضع في اعتبارنا أن قوة البشرية ليست في الآلات القوية التي نطورها، ولكن تظل في ذكائنا وقدرتنا على تطوير حلول للمشاكل على المستوى الأساسي. وأنتم اللي كتبتم هذا. نحن محظوظون بوجود الدكتور حسين الكتاني، أستاذ بجامعة كارولاينا الجنوبية الولايات المتحدة، وهو مغربي، وكما قلت قرأت في التغريدات من خلال ما يكتب على السوشيال ميديا أنه يحب بلده ويحب البلدان الإسلامية العربية، وكتب كتبا ربما يتحدث ربما عندما أثناء المناقشة على هذه الكتب، أتمنى. فهو يتمتع بخبرة أكاديمية تزيد عن 20 عاما في ميدان علوم الكمبيوتر، وأشكره على محاضرته، وأترك الكلام للسيد أستاذنا الكريم.
حياك الله. شكرا بروفيسور أحمد، يعطيك الصحة والعافية. وشكرا أيضا للبروفيسور حسين، الله يعطيك الصحة والعافية. ما شاء الله المجال الحاسوب جميل جدا صراحة، وخاصة هذه الأرقام الكبيرة. ننتقل إلى الفقرة الخاصة بالأسئلة والمداخلات والتعليقات، وهنالك البروفيسور عبد الإله بن يوسف أول المتداخلين. تفضل بروفيسور عبد الإله.
شكرا أستاذ سالم. شكرا جزيل للأستاذ حسين كتاني على المداخلة العظيمة والممتعة. لقد أمتعتنا بهذه المحاضرة أستاذ كتاني، شكرا جزيلا. لدي بعض الاستفسارات فيما يخص quantum computer. Are we now in the area of quantum simulators or quantum computer with as a universal one?
Assalamu alaikum, Dr. Ben Yusuf. Currently, we are in an interface. So yeah. So it's not there are many issues with quantum computing, but the research is very active in that aspect.
Okay, and the related question is on the number of quantum bit now as a record of the simulators or computing computers, quantum computers. What is the record now?
Well, Google had a processor, sycamore processor, or a quantum computer that they showed that on an application that it would take a problem specific that would take supercomputer 10,000 years to solve. They solved it in a much shorter time. So they proved for that particular problem that the quantum computer could be trillion times, that is a million times of a supercomputer, of the fastest supercomputer. So it's still debatable. Measurements vary, so there's no standard measure like flops. You can see, like for supercomputers, you use the word flops, but for the quantum computing, you can use flops also, but it's still it's still a well-functioning quantum computer still is not believed that it's out there yet. So that can work on every problem.
But in the material science, there is the need for the fabrication of quantum bit, like NV center or topological insulator in superconductor. And this is a big challenge to make that, a very big challenge, because it needs a very low temperature and and also fluctuation, quantum fluctuation, thermal fluctuation are a big challenge to do that. For big computer with a big number of quantum bits, it's a very big challenge to have sufficient qubit to make universal quantum computer.
But that's what researchers do, is they are up to the challenge.
Yeah. Thank you very much for your very nice talk, Dr. Professor Houssain Kettani. Thank you very much.
Thank you, Professor Benis.
Thank you, Professor Ben Youssef. Let's go for the second Professor Dr. Nasser. Please welcome. Dr. Nasser, you are there.
نعم طال عمرك. السلام عليكم ورحمة الله.
حياك الله.
شكرا جزيلا دكتور حسين الكتاني. يعني أنا فخور كعربي بإني أستمع إلى قامة علمية مثلك. أنا سؤالي بسيط جدا طال عمرك. توقعاتك بالنسبة لاستخدامات الكوانتم كومبيوتينج في قضايا مثلا سايبر وورفير، استخدامات الطاقات المتجددة، قضايا الطب الآن والتقدم في معالجة بعض الأمراض المستعصية مثل السرطانات وغيرها، قضايا مثلا حروب المياه القادمة، استخداماتها بنوع من الأسلحة اللي مرتبطة بالطبيعة وممكن استخدامها ضدنا. ودي يعني أسمع منك المستقبل، ارتباطها مثلا في قضايا التنمية المستدامة، 17 هدف الأمم المتحدة، شلون نقدر نستخدم هذه القدرات الكمبيوترية في معالجة بعض الأمور اللي دول العالم كلها قاعد تعاني منها. وأيضا عندي سؤال بسيط، يعني سامحني بس أنا قاعد أقوله هو من باب النكتة ومن باب الحسرة مع بعض. في كوانتم كمبيوتر مثلا يقدر يساعدنا في حل مشاكل الأمة العربية؟ لأن أنا حاولت طال عمرك بكل الكمبيوترات اللي بالدنيا ما لقيت كمبيوتر إلى الآن يقدر يحل هالمشكلات هذه. حتى العقول اللي دخلت لحل مشاكلنا هاجرت. فبدي أسمع منك إذا تكرمت طال عمرك، وجزاك الله خير.
السؤال الثاني أسهل من السؤال الأول. العقول لم تهاجر، العقول هجرت.
هجرت اي والله.
نعم.
أنا يعني ما كنت بعيد عنك، أنا كنت في نورث كارولاينا في ساوث كارولاينا، وبعدين شفت بدال ما مكان آخر هاجرت، رحت إلى الغرب وقعدت في اليو اس سي، فكان لي أبرك وأحسن يعني. إنما حقيقة دكتور يعني أنا أشعر بألم كبير أن بالرغم من كل هالتكنولوجيا اللي عندنا لكننا لازلنا نعاني. فبدي أستمع منك للواقع شلون نقدر نتعامل معه، ثم المستقبل كيف تقرأه بوجود الكوانتم كومبيوتينج.
Quantum computing presents the element of speed in processing power. So with that, we can solve problems that we already try to solve using supercomputers. So as you said, you can, all the problems that you talked about, these are quantum computing, a functional and stable quantum computer would help a lot to solve these problems and find answers. For example, like if we are talking about, like Dr. Nawi said about COVID, like how to simulate its spread, how to do DNA sequencing to estimate what kind of variable or change in sequencing going to happen, and what is the impact of that. Can you influence that one way or another? Can you force the virus to change its structure in a way that it becomes less lethal or less infectious or something like that? So all these are open problems that with fast computer, let's not call it supercomputer, because supercomputer is the binary one, and then you have quantum computer, which is supercomputer. You can, with the much faster computing resources, you can analyze more data. You can train your algorithm to learn better, to be able to analyze things, and to find solutions to problems that were not solvable in the past. So you can add, and this is very useful when you are talking about permutation problems, where the only solution for that, like trouble in salesman, the only solution is to check every solution, every possible possible case. And when you don't have that kind of speed, you cannot check every possible case, but you have a random set, and you hope that with the random set that you analyzed kind of all possible things. But with a faster computer, you can add more and more to the set, and maybe even study all possible scenarios, and that would give you a real solution to a problem that you are looking at.
Thank you. Thank you, Professor Houssain. Any other questions or comments, please? Here we have from Abdus Samad Ibrahim. He's saying, is the original strength in hardware side or SOST side? What do we mean here? Where cloud we use in Arabic word? Did you got it, or please, Abdus Salam, if you want to ask it in your way. Did you got his answer or a question, Professor Houssain?
Yeah, well, if we start talking about the Arabic word, I think we know the problems of the Arabic word. I think we all agree what are the problems. So I don't want to talk politics or anything, but as natural resources in the Arabic world are exploited, also human resources are exploited. So so we have all the capability, we have the brains, we have the strength, we have the homogeneity, we have human resources, we have so that's so we lack nothing, and we don't even lack the will. So we I don't think that there is any quantum computer in the Arab world or the Muslim world, and if you see the top 10, you don't see any Arabic country, or top 20 and the fastest computers in the world. But there are some really fast computers that are on the top 500 list. I think 2 of them are in Saudi Arabia, one in KAUST and one in that King Fahd UPN or so. But I don't know how these are used in real research. What is their impact on real research? The thing about the supercomputer at Oak Ridge National Lab, you may see others on the list, but that one, the United Nations uses it for climate change. So that's pretty much really used in scientific frontiers. So so some other countries, they may have a supercomputer just to say that we are on that top 500 list, and it's managed by people outside the country, so not by locals.
Okay, got it. If there is any other things, Mr. Abdus Samad, he said that SOS side, he mean the software side. Okay, in short, he write it. Anyhow, Prof. Ahmed, do you want to comment, please?
Yeah, sure. I have to ask some questions in the same sense than just what was discussed a few seconds ago. I have the feeling, I think it was last week or 2 weeks before, there is something happened that YouTube, WhatsApp, and all this stuff doesn't work anymore. For few hours or for a few minutes, and for hours. Yeah. Yes. Okay, and then everybody look to United States, that everything happened there in United States. It looked like if we are in the hand of the United States when it is about communication, IT, and all this stuff. then I ask myself, what United States have better than Arab world? I say money, I guess. And there is also technology. Why? And you don't want to make politics, but we will push you there, unfortunately. Why, if you ask United States to buy weapon, even very highly killing, not killing, but killing weapon, they accept it. You can buy even maybe atomic bomb, maybe. But if you want to buy the technology, it's not easy. Why? And the technology is the most peaceful stuff. Where is the problem? And I don't believe that a human being from Morocco or from Germany are different than the politician in the United States. And even I find the politician in the United States very sympathetic for me, at least when they talk, etc. So where is this problem? Why we are fighting against each other and we don't want to go to something which is very easy, is just to have very peaceful technology. And I'm talking, of course, I will go back to the computing. So I have the feeling if one day United States want to close all this social media and all this stuff, we will be in trouble. Of course, they will pay. They will lost a lot of money, like the last time for these few hours. But I would like to know what is behind this. Is it the power? Is something else? For me, the power is the only one power I know is God. The other, I don't believe it.
Do we follow him?
Yeah, it's actually, yeah, that's true.
But
Yeah.
well, you can to answer your question. I think you know the answer. But you can see the problems now between China and the United States. When China became very good at 5G, you can see it's no longer became a scientific competition. They arrested the CEO in Canada and of Huawei and accused them of various accusations. And the answer of that by China was to arrest diplomats, Canadian diplomats, to hold them hostage until they released. So with 5G is the real problems that started now between United States before COVID and China. And I went to China many times, and Facebook was already blocked in China. Gmail was almost blocked there, so, and Google and stuff like that. LinkedIn now banned in China. So China have their own software. Have Twitter doesn't work there. They have WeChat, and they use it as Facebook. They use it for chatting. They use it for payments. They use it for. They hardly use cash now in China. So China is developing its own system, its own world, and they realized early on that Facebook can be used for espionage, for manipulating the population, and Russia learned that and used it against the United States in 2016 election. So if there is, whenever there is a will, there is a way. But the problem with the so-called independence agreements of many countries in Africa and the Arab world, part of the agreements is that you have to buy things from your previous occupier. So there's no competition. If you see the problem, if you see, for example, in Morocco, there's no competition. You have to buy whatever stuff from France, even Danone. And so they are making a lot of money, and to some degree, even natural resources, you wonder whether they are owned by the state of Morocco or owned by France. Like some say, the independence, the agreement was that we hold what is on land, but they continue to hold what is under the land. And so with such unfair economic relationship and social relationship, of course, always a country going to remain on the top. And you have like 15 countries or more in Africa, sub-Saharan Africa, the economy is totally belongs to France. So you wonder, so if you get resources, raw resources for free from these countries, and you force them to buy it from you, and any income that these countries have, they have to store it in your own bank, and they cannot take whatever they want. They take only a percentage, and if they want extra of their own money, then they borrow it from you with interest. So the same thing also in the United States. Like the United States, the dollar currency is something that is the whole world runs after it, but it has no reserve. So in the United States, every 6 months we have a $2 trillion stimulus. Where does it come from? It's not even printed. And the American population, we are getting money every month from the government just to help us with COVID, and it's just free money. So so a country, for example, like France, with all the wealth that it has a national debt of $5 trillion. So in Morocco, if they want to borrow like $100 million, then they have to go through some really a kind of unfair or stringent agreements. How are you going to return it, or you need to release people, or you cannot invest in some other things, including healthcare, including research and other things. So again, it's I think the reasons are well known and beyond science.
Yes. So in two words, after the Second World, we had the occupation from France in Morocco, some place, the Commonwealth, etc. That's the occupation 1.0. Now we have the occupation 2.0. And if it's finished, we have to go to occupation 3.0, 4.0, like technology, I guess. So we will spend all our life occupied by the West. I have the feeling, because we don't have the right people in our governments.
No, I think you live in the West, you live in Europe, and I think Europeans feel they are occupied too. There are special interest people in Europe and the United States that the population itself feels it's occupied. So now the occupation that we talk about in Africa, now Europeans feel they are occupied. And that will change, because you have an exponential growth in debt that is unsustainable, and it has to it will stop just naturally. Any exponential function, naturally it has to collapse.
Yeah.
But so we are like but if you see Morocco, it may be poor, but at least people don't have debt. People are living kind of well compared to European countries or United States, where everybody's on debt, and then you have all kind of social problems that come with that.
Yeah. Thank you.
Before ending, Professor Houssain, can you give us a little information, short information about your books, as Professor Ahmed, he was talking about it in the beginning.
Oh, okay. Well, I gave keynote speeches about it before. I can give it some time, but I'll just try to find something and then share it quickly.
Yes.
Okay, here I'll share it quickly. I'm trying to find it. Okay, here it is. Do you see it?
Yes.
Just make it full screen, please.
Yeah, well, I'll try not to go through it, but this is my latest book. And actually, this in 2020 and in 2021, I had it also in Arabic. So this is a book in English. You can have the ISBN number or the title. You can Google it and find it. You can buy it from Amazon. You can order it from the publisher. This is the one in Arabic. It was printed in Beirut, Lebanon by Dar al-Kutub al-Ilmiya. And that's also and the interesting thing, the book in Arabic is sold for $40. The book in English, $160. So the book in Arabic is like 1,200 pages. The book in English is 900 pages. But just to see. So here are some blurbs from researchers that talked about the book. So this from Muhammad Abu Lays from the UK. This book contributes towards developing a dependable platform for research students, teachers, authors, historians, biographers for many centuries to come. It may be the first largest data set in history for this subject, a unique book for those who have even a little thirst for Muslim history or populations. Another one from Pew Research Center, a researcher there, he said, Muslims are the fastest growing major religious group in the world. In this thorough volume, Houssain Kettani assembles country by country estimates and descriptions of how Muslim populations have changed in size and as well as linear extrapolations of future growth. This is a valuable resource I am glad to have on my shelf. Another one by Dr. Awami Anjum from the University of Toledo. Dr. Houssain Kettani makes an important contribution to historical Muslim population studies. Its scope is breathtaking and its information value immense. It should spark much research, refinement, and development and advancement of this nascent area of study. And another one by from Turkey, Dr. Kemal Çiçek. We are all curious about the evolution of the Muslim population in the world, and Dr. Houssain Kettani seems to have undertaken an enormous task to make a thorough and reliable estimate. This is undoubtedly the most satisfactory and thought through of the recent books on the subject that I have seen. So I talked about the challenges, how you define a Muslim, who is Muslim, and how to get the data. I try to count on censuses whenever available, and then the sources for total populations. There is Angus Maddison, who studied the population in each country, because I did the analysis since 600 AD until 2100. So Angus Maddison did a study of population in each country in its current border based on the economics. So he made that estimate. And then since 1950, you have the estimate until 2100, you have the total population of each country is updated every other year and is provided by the United Nations World Population Prospects. So there were previous attempts. The earliest I can see is a German called Hubert Janssen, and in the 19th century, and he made a global analysis. And then there is a French Orientalist, Louis Massignon, and he published several books in 26, 29, and 1955. There is my father, Dr. Ali Kettani, who also he used to work at University of Petroleum and Minerals. Actually, I was born there in Khobar, across the bridge from Bahrain. And he did a book in 1986. He was also the general director of the Islamic Foundation of Science, Technology, and Development in Jeddah, that was under the OIC, Organization of Islamic Conference. And then was Pew Research Center in 2009 that made, I'm talking about the global, I'm talking about each country. And that's the uniqueness of this work by Janssen in 1897, that it's global. So here are like censuses, each country, and how many Muslims are there, a percentage of each in 2000 and in 2020. So, okay. So here's an example of Morocco. So in 1910, before the French came, they were about almost 97% of the population was Muslim. With the French occupation, there were many French settlers, so that reduced to 92%. And then when the French left, and many of the Jewish community went to South America or France or to Palestine, then it became 99% and Muslim, and then later they stopped having the census, they stopped publishing the data on religion. Here's France, for example. You can see that there were almost nobody, just few hundreds in the 1860s, etc. And this is based. So this is an estimate based on ethnicity, on origin. But then you can see that after the 60s, when more countries got independent, and after the war, actually after World War II, they needed manpower. Europe needed manpower, the United States needed manpower, so they opened the door for immigration. So Muslims played a vital role in the prosperity of these countries, of European countries and the United States after the World War II. So you can see, so when you hear all these, like the survey showed that 14% in 2018 of French population is Muslim. So it's you see the growth. So that's why you hear a lot of such nasty talk from Macron and from some people there that they are scared about Muslims, but they only bring stability and prosperity to the country. So this is an excerpt from my book. I say Islam in Europe is a matter of diversity and necessity. Western Europe started having migrant workers from Muslim countries after World War II to stimulate its economy and cover for shortage of manpower. Thus, Muslims were instrumental in the economic prosperity of Western Europe and Europe at large. In addition, as more Europeans leave Christianity, Muslims present Europeans with another spiritual life in which many Europeans find satisfaction and answers to their long puzzling questions. In this context, Islam may be a cause of stability and prosperity to Europe. Understanding the history and appreciating the numbers of Muslims in Western Europe may help in developing better relations between Christians and Muslims in the West and worldwide, away from political slogans, ethnic slurs, or misuse of religion for worldly gains. And so here's an example of population in China. In China, you have like religion goes through ethnic lines. The same thing, like because they don't collect data on religion, but they collect data on ethnicity. The same thing on former communist countries like former Soviet Union. So that's how I estimated Muslims in those countries. There is spatial distribution. So each country, each state in the United States where there's a concentration of Muslims around the world. And so total Muslims in 2010. So here is a graphical illustration of Muslim increase. This is a world war, the whole war. So in 1950, 1 out of 7 of world population was Muslim. In 1970, 1 out of 6. 1990, 1 out of 5. In 2020, 1 out of 4. And so by 2070, we expect to have 1 out of 3 of the world population as Muslim. And here's population increase. Okay. These are various statistics from the book. Again, causes of changes. What I see is mostly fertility and migration, some conversion, but it's hard to get those data. So here's the growth in Asia. So the green one is percentage, and this one is the population, percentage of the total population. In Europe, it's growing. So you hear a lot of people talking about Muslims taking over Europe. That's not true, because even at the end of the century, you are just going to have 13%. So just trying to spread hatred. There is nothing like that. And there is this French demographer. He said, I say it in English, he said it in French. These estimates based on likelihoods constitute the first step to the truth and the only proper way to criticize them is to displace them by more accurate ones. So whatever I present in the statistics is an estimate. And so here is the book in English. You can get a 20% discount, and that's it.
Thank you, Professor Houssain. It's wonderful.
Thank you.
Right, so we come to the end. Before ending, Professor Ahmed, you want? I will let the last comment to you. I will let Professor Houssain your last comment or say. Please welcome. ماذا تريد أن تختم بنهاية هذه المحاضرة? What you want to say about?
أنا؟
Yes.
بارك الله فيكم. شكرا جزيلا للاستدعاء والفرصة للتكلم عن بعض البحث العلمي وبعض الكتب كذلك. Thank you very much for the opportunity. It's great to meet researchers like you from all over the world. And thank you, Dr. Nawi, for the initiative. And hopefully it's gonna grow, and hopefully we will continue to meet from time to time and discuss different topics. Hopefully we can stimulate more students from our region, that they can succeed and network and be able to help our countries, and I say countries with S, and because we belong to several countries. And I think it's a great initiative. We just need to see more collaboration with the universities in Morocco and other universities in the Arab world, and even beyond, for the sake of helping the region and stimulate research there. When I communicate with students from Morocco, they are bright, they are energetic, they are excited. And when I see the opportunities that students have in the United States, I compare it with the opportunities that Moroccans have. There is no comparison. And so if Moroccans get just a fraction of that of that help, I think they can achieve a lot and a lot. And I think by just them seeing a role model, a successful role model, away from all these stigmatizations and negative energy that you see it from time to time on social media and on TVs, I think our younger population has a very bright future that they can play an excellent and a positive role in.
Thank you.
Thank you very much.
I will give also Professor Ahmed Rasili. He didn't get the chance previously. You want to say any comments, Prof. Ahmed Rasili?
Just to say that I'm happy to meet such a really a nice presenter, and then also very, very, very great scientist, and also with other facets which I really like too much. I want to when presenting, I was going through your LinkedIn. I saw a lot of comments and really nice thing. Really happy to have met you today, and many thanks to those who make this happen. Thanks Allah.
Alhamdulillah.
Thank you very much, Dr. Rasili.
Right. So closing from Professor Ahmed, please welcome.
First of all, thank you very much. I expect from you such performance, and very clear and crystal clear, and also about your book. تكاثروا فإني أبالي بكم يوم القيامة. أظن أن الأشياء واضحة، وعندنا يعني علماء من المغرب موجودين في خارج المغرب في أوروبا وأمريكا، وعندهم يعني ثقافة ليست فقط علمية بل عالمية، وبالتالي يعني يجب أن نفتخر. وأتمنى أن جامعة التعلم الافتراضي هتكون يعني منبر لكل المغاربة داخل المغرب وخارج المغرب، لكي يعبروا عن علمهم، عن سياستهم، عن their religion and everything in the future. And they said, we will do it. We will do everything for that. And I think we will. We hope that we can always invite Dr. Houssain Kettani to talk to us about the update of the computing. I think the computing are running very fast, and quantum computer and standard computer, if we can say that, are getting something together in this interface. And he will always bring us the update, and we will invite him every time he has time. And I want to thank him and to thank everyone here who listened to us, and we hope to will continue. And just at the end, maybe Ustad Salim, you can say us for tomorrow, or you want me to do
Yes.
it?
Okay, for tomorrow, let me.
I have it on if you like.
For day 10. Yes. Day 10. Let's go for day 10. And you can talk. I will share it. You can have it. Please go ahead. This is day 10 for tomorrow.
Okay, so tomorrow we will have Professor El-Bari, Houssain El-Bari. He's in Kenitra, the university in Kenitra. It's called University Ibn Tufail. He's president of the Moroccan Association of Solid West, and I think it's a compliment, is a continuation of the talk of Dr. Ahmed Rasili today. That's why Ahmed Rasili is in the panel tomorrow to animate a little bit and so on. So he will talk about his activities and the solid waste and the how to go from waste to bioenergy and biofuel, etc. And he's doing really experiment and working really to make things going from the lab to fab. And you are welcome to listen to him tomorrow. I think we can also show for after tomorrow, or we just stop here.
Okay. If you want to,
I have it. I have the.
You have it. You can go ahead.
Yes.
Okay.
Okay.
You can go for the.
So you take this out.
Yes, it is there. You can go ahead.
Yeah. Then I will share. We will have a very interesting talk after the day after tomorrow, and it will be it's Dr. Professor Evan Gordon. He's the editor in chief of Solar Energy Material and Solar Cell. That why I know him, because we are both in the editorial board, and he's the editor in chief now. Before it was an American, Dr. Lambert, and now he's the one editor in chief, and he's very known since he's the manager of photovoltaic technology and energy system in Belgium, and he's professor for digital photovoltaic at Delft in Holland, Netherlands. And they think he will talk about the status of crystalline silicon, and that's his field. So this is one which will be after tomorrow, 28, Tuesday. Then the same day, this is at 11 a.m., and the same day will be it's we go again to recycling and so on, and it will be Dr. Saad. He already have given a talk, I think, last week. Now he will talk about the water reuse and solution to water scarcity and sustainability. And he's in Canada. He's the president of the International Ozone Association, and he's also consultant in Widson. So both are very good talk, and they will be delivered by experts, and you are all welcome for this talk. So I give you the floor, Ustad Salim.
Okay, so we came to the end Thank you for all for participating in this lecture. Thank you also to our speaker, Professor Houssain Kettani. We were so happy that you are with us today. Thanks to Professor Ahmed Wasili, Dr. Nasser, and all the participants, Dr. Abdulillah bin Yusuf, and Professor Ahmed Naum. So we will see you tomorrow, inshallah, at 11. Ma salama.
Tomorrow. See you. Assalamu alaikum.
Alaikum salam.